Hi everyone, welcome back to my next video lecture. That is my video lecture topic is today's topic is kinetics of phase transformation. Yeah, so kinetics of phase transformation. And as you know this is Sachin Kumar from Department of Material Science and Engineering, IIT Kanpur, working under the supervision of Kaustubh Kulkarni. And my research topic is diffusion in ternary alloy, nickel based ternary alloy. Let's begin with our overview of today's lecture. This is a complete overview. We are covering very less topic, that is classification of phase transformation first of all, and the nucleation and the growth, introduction to nucleation and the growth. In this one we have two different type of nucleation, that is a homogeneous nucleation and a heterogeneous nucleation. We are covering a homogeneous nucleation, that too a small part. This is a part 1, and in upcoming videos I have divided that homogeneous nucleation part 2 and its problem, and finally we will conclude this phase transformation, kinetics of phase transformation, with the heterogeneous nucleation and its problems. This is a complete video lectures. Two video lectures I am covering on phase transformation. So accordingly, there may be one more additional video may come on this phase transformation. Okay, let's begin with this classification of a phase transformation. So before getting into the phase transformation concept, so what's the reason behind studying of phase transformation? Phase transformation Phase transformation is important in processing of materials. Processing of material. During processing, there may be a chances of formation of a new phase. At least one new phase will be formed, and due to this formation of new phase, there is a change in the properties of material. Property change. This can be used in different applications. This property change can be used in a different applications. Hence, so this phase transformation will tell us what type of new phases that is formed, how they are forming. So what are the parameters such as temperature, cooling rate, and the material that have been used for the phase transformation. These are some parameters that can control the phase transformation. So we can study these all the things under this topic. So hence the study of a phase transformation plays a vital role in the material science. Next thing is nucleation and the growth, and after this homogeneous nucleation. First of all, we are jumping into the classification of phase transformation. So this is classification of phase transformation. Here I have written only two classification, but one more is there that I will tell while I am explaining. First of all, diffusion dependent transformation and diffusionless transformation. In this one, there are two categories there, in which the transformation, after the transformation, there is no change in composition, whereas diffusion dependent transformation, there is one more category, is that there is a change in the composition. Can anyone tell me the examples or write examples where this diffusion dependent transformation takes place without changing its composition? Please write it in a comment box section. Okay. So next, compositional changes. So everyone knows, that is austenites are transformed into perlites, are a good example from diffusion dependent transformation with the composition changes. So this is having one composition and this perlite is having different composition. This is a good example for this one. So next one is diffusionless transformation. So diffusionless, wait a minute. And the good example for the diffusionless transformation is Martin-Settig transformation. Martin-Settig transformation is a good example for the diffusionless transformation. Here, the carbon atom will diffuse half of the atomic distance. Because of this reason, it is considered to be as a diffusionless transformation. Here, when the carbon atom will goes into the interstitial sites of a iron, it tries to want to be in a BCC structure, but but it's due to high activation energy, it won't be in a BCC structure. Hence, because of instead of BCC, it will getting into the BCT structure. Body. Okay, so next we will getting into the introduction to the nucleation and the growth. A whole phase transformation is divided into two steps, that is nucleation plus growth. So what is meant by nucleation? Nucleation involves appearance of a very small particles or a nuclei of the new phase at the preferential sites. It's called nucleation. There is a new phases will be formed inside the parent material. That's called as a nucleation. And nucleation, after this, there is a growth. So once the nuclear atoms will clusters, these are the atoms, they will combine, forms in a small nuclei, which is having a new phase. This is a new phase. After this, there is a growth. All the nucleus will join together. They form a complete one phase. This is called growth section. Again, we are getting into this nucleation. Nucleation can be divided into two parts. There are two types of a nucleation. There is a homogeneous nucleation and the heterogeneous nucleation. A lot of differences is present in between the homogeneous nucleation and the heterogeneous nucleations. So in upcoming videos, we are getting in-depth knowledge of homogeneous as well as heterogeneous nucleation. Before getting into the each and every type of nucleation, we are differentiating. So what is the main differences between homogeneous as well as heterogeneous nucleation? So first of all, definition. Homogeneous nucleation is a process of nucleation that takes place away from the surfaces. That means the nucleation will take place without any preferential sites. This is a wall of the container and this is a parent material, and the nucleation will take place in the middle of the parent site. But whereas in the heterogeneous nucleation, it will takes place the help of the surfaces. For example, this is a parent site and this is a wall of the container, and the nucleation will take place at the wall of the container. This is preferential sites. Wall of the container, preferential sites, and nucleation will take place at a preferential sites. For example, wall of the container, grain boundaries, etc. This is a nucleation site as I explained in this one. And the speed of the nucleation is very slow and very fast in that of the compared to that of the heterogeneous nucleation. And so what in nature of the nucleation, it's very less because it requires it will take place within the parent material, which is very difficult, right? So, and whereas it's commonly found in everywhere regularly, if you solidify the any liquid metal or any liquid items, it will get nucleus will be found at the grain boundaries or the wall of the container. That's why first it will grow here at the wall of the container. Again, the larger grains will be found at the center. This is heterogeneous. Due to that, this is heterogeneous nucleation. Whereas a free energy barrier, I will explain in depth in the upcoming videos separately. There is a homogeneous as well as heterogeneous free energy. Just because of differences, I kept this point here. This is common plot. You will see in the upcoming videos. This is a free energy versus radius. And this is for homogeneous nucleation. So heterogeneous nucleation, and this is for homogeneous nucleation. There is a free energy barrier for the heterogeneous nucleation is very less, and whereas for the homogeneous nucleation it is too large. So why there is a lot of differences in the free energy, I will explain in the with the help of equations in upcoming videos, right? So we will, last point is surface area. Surface area that the contributes to the growth of the nucleus is high, whereas for the heterogeneous nucleation, the surface area that the contribute to the growth of the nucleus is very low. Okay, so this is a basic differences that can be asked in any of the competitive exams or any of the interviews for this heterogeneous and homogeneous nucleations. In most of the PhD interviews, this is the common differences they will ask everywhere. Okay, thank you. This is the end of the lecture. So in upcoming videos, we are moving into the in-depth knowledge of homogeneous as well as heterogeneous nucleation. Thank you.